Hello, everyone. On behalf of the Industrial Fabrics Association International, welcome to the webinar, Navigating the First Prototype Conversation, 5 Questions You Need to Ask. My name is Magda Rodigan. I am the National Program Manager for IFEI's Makers Division and today's moderator. The Makers Division supports the sewn products industry and any machine operator in the industrial fabrics industry. As a leading international trade association, IFEI helps members thrive by providing education, marketplace presence and trade shows, networking opportunities, resources, and recognition. So if you're new to IFEI, we invite you to join our vibrant trade association. Before we get started, I'm going to go over a few items so that you know how to participate in today's event. You'll have the opportunity to submit questions to today's presenter by typing your questions into the questions box of the control panel. The questions will be collected and addressed during the Q&A session at the end of today's presentation. The webinar is being recorded and will be available to IFEI members in the future in the IFEI video library. And a PowerPoint of the webinar is located on the sidebar for downloading during the presentation. I would now like to introduce you to our presenter, Chad Miller, Director of Contract Manufacturing at American National Manufacturing. Chad began his professional manufacturing career 20 years ago. In 1997, Chad and his father, Craig Miller Sr., started a contract manufacturing business where Chad was the managing member. In 2010, Chad and his father merged their business with American National Manufacturing, where Chad was named the Director of Contract Manufacturing. Together, they have led the division to record growth with over $3 million in annual sales. Chad has over 20 years of experience in designing, engineering, and manufacturing products in the medical and consumer sleep systems field, inflatables, water bladders, foam products in medical and non-medical applications for the aviation, recreation, marine, and safety industries. Chad is an inventor with 2 patent filings, which resulted in his creating an entire line of products designed for preschools, hospitals, and other educational facilities under the brand name Happy Child Products. Chad has been the general manager of Happy Child Products brand since its inception over 6 years ago. He's a board member of the Corona Chamber of Commerce and State Legislative Action Committee member, and he is certified in OSHA 511 standards for general industry, as well as being a certified instructor for the Red Cross. Welcome, Chad. Thank you so much for sharing your expertise today.
Of course. Thank you for the kind introduction, Magda. Pleasure to have everyone here today. Thanks for attending, and I hope that this information will help you in your endeavors to either starting a business, growing your business, or identifying new ways to really take what I think is one of the most difficult aspects of my job, and that's to take what your customer has in their mind or on a napkin drawing, or maybe they have a full technical package, and how to get that from exactly where it's at to where it needs to be for mass production and distribution throughout the national and international business world. So we'll go ahead and dive right in. Going back just to share a little bit, my actual rewinding the clock back, my actual education started off to be in recreation administration. And I learned how to eventually run programs where you're entrusted with the lives of all ages and programs for the YMCA of Orange County way back in my college years in the 1990s. Throughout that, I took a lot of business courses because, of course, we have some fiscal responsibility, and learned to basically go from administering recreation products to getting sucked in back into the family business, where my father started the business in 1975 making water beds using radio frequency sealing machines, which I grew up in the factory. Believe it or not, I was driving a forklift when I was about 10 to 12 years old, unloading trucks and doing inventory. So back then, a family business. My brother, myself, and my younger sister was too young, but we have grown up in a factory setting, working all aspects of the business. So everything from warehousing, receiving, quality, accounts payable, purchasing, credit department, marketing. So our family has grown us up in that. And then in my college years, I decided that I want to kind of steer away from that and went into recreation administration. And after about 4 years of that and getting almost done with my bachelor's degree, fell just short of that by about a year because my father came to me with the need of starting this contract manufacturing business and to make the connection between American National, which is a business my father and I owned and ran. American National started off, like I said, in the 70s making water beds and then reinvented itself in the mid-90s as a manufacturer of adjustable firmness air mattresses. So that being said, Plastech was a company my father and I started to basically make medical and contract manufacturing products. And we grew that business to about 12 different industries. And to 2010, we merged our mattress. My mom and brother owned and operated American National Manufacturing. There was a mattress company, and we merged the contract manufacturing company my father and I had all to one big company now. So we're all under one roof, so to speak. So now I'll tell you about American National as it is today. So this is what I just had talked about. Currently, we're in 3 locations. We possess over about 190,000 square feet of manufacturing, assembly, and distribution space throughout the country. And then we currently have about over 200 employees now. We have a very large RF welding department. And we have over about 100 sewing machines. That number grows pretty much every month. This first picture here is a picture of where I'm sitting currently today in our Corona, California headquarters, which is 76,000 square feet. We do have a brand new, about 6 months now, we've been in this Riverside, Missouri. We have 80,000 square feet there of assembly and distribution. And then we have recently opened 2017 mid-year. We opened a facility just south of us here in Mexico in a great little town called Tecate. We have a 37,000 square foot facility there where we do all sewing, cutting, sewing, and assembly of mainly our consumer sleep systems. And this slide just shows kind of what our cutting operation and sewing operation does look like. We have several automated cutting machines photoed here on the top. We do have a sewing department, like I said, which is depicted here, 2 of the production lines. And these photos are only of our California facility. So you would see this kind of duplicated at the other locations. Our industries listed here are some of our major ones, our medical, consumer, safety, aviation, education, and then we do quite a bit of work in the environmental industries as well. So I won't bore you too much with specific products there, but here's a great shot of one of our production lines. This happens to be our turntable area of our RF welding department. We do have some of the largest equipment that you can actually, I think is in the country, 175,000 watt machine. That welds 120 inch by 93 inch area. That's how large of an area. And that machine comes back from the 80s making waterbeds. So imagine a king size waterbed that would have been made on this machine. So a very large RF welding operation that we have. So now let's go ahead and talk about the objectives of today's meeting here, our webinar. So the first thing that I'd like everyone to gain is basically to have tools to use when you're sitting down for your first prototype conversation. The next objective would be to basically have resources should you need assistance and to gather more information and to understand the prototype and R&D process. It can be quite burdensome and frustrating, and I found that having these things, the right tools, can help that process. And then know the right questions to ask, which is going to be critical. And during this webinar, you'll see how not having these questions can really lead to a difficult path. And then to know what information will be needed to go to the next step, which is properly quote your customer that's seeking your guidance and your expertise in manufacturing. So let's talk about that, finding the fit. How do we know if a customer is right for us? So the first thing we need is to establish to find out if this project is a good fit for our factory. That's what I usually do. And in order to do that, there are several things that I need to determine. So the first thing is, do I have the right equipment? I just showed you slides of our equipment. It's important to know what equipment you do have. Do I need equipment that's automated? Do I need something that puts something on top of something? And you know, there's so many different processes that we use. I may or may not have the right equipment. An example of this for us is we were contacted, if you recall back many years ago, there was a Southeast Asia tsunami. And we don't make body bags, but the Department of Defense contacted a lot of people looking for anyone who could make them to make them. And we've never made one before, and we didn't have the right equipment for it, so it wasn't a good fit for us. However, we were contacted by a company who was making them and needed to expand their operation. So the equipment I didn't have was a riveting machine that would rivet a specific rivet onto the webbing, which was attached to the bag to allow the bag to be, to be able to have the handles on the top, middle, and bottom. So we didn't have all the right equipment. We didn't have the materials. And so this was doomed to the start. However, with the support of our customer, he provided us the equipment. So we went from not accepting the project to accepting it because we got what we call a gap. We had our production gap filled with our customer's assistance, and it worked out. The second thing is having the right talent. So again, for that example, we didn't have anyone trained on doing this, but we do know how to sew. And we know how to sew zippers to bags and the 18-ounce vinyl laminate, which was used. And so we currently didn't have it, so a decision has to be made. If I don't have the right talent, can I get it? And if so, do I have the ability to train that talent if I have them? And next is, do I have the time? And basically, that has to be determined by looking at the project timeline the potential client has. I have calls where someone is expecting to be at a trade show, in 30 days from now. Or they went to a trade show with prototypes they've made, and now they've got big companies looking to distribute or become dealers for their product, and they expect to be production ready in 3 months, which is just unrealistic. So the question is, how much time is it going to take, and is the timeline aligning with your ability to deliver? And then, are the materials, tools, and aids available in that time frame? A lot of times when I have a project I'm looking at, there's a specific thing I need I don't have. Can my machine shop fabricate something in order to be able to even make one unit? Or if it's beyond prototype and it's something in production, has the customer basically delivered to me what I need to be able to purchase if it's a special material or special piece of equipment that I need to be able to run mass production? Are they investing in their product and their production as much, if not more, than they're asking me to? So that's another thing that I always consider. And then in general, do I have the resources available to be able to take on this prototype or this project, whether it's a already developed product or whether it's something I'm helping with the R&D of? And that goes to say is, do I have the knowledge of the industry or product? Currently, I have a project that is regulated by the IMO, the International Maritime Organization. I know that I don't have experience making products for the Maritime Regulated Organization for anything that goes on a cruise ship, but I have a product I'm working on that is a medical product for use on a cruise ship, and I'm having to learn this industry, and I had to determine I don't have the resources, but the customer is really doing the heavy lifting for that. And so you have to decide whether or not that's something that you're willing to take on, is gaining the knowledge if you don't currently possess it for a specific industry or a type of product within that industry. Secondly, space. One of the projects I was presented with was making industrial curtains for wrapping automotive facilities. If they're currently these aluminum bodies that come out, they have to separate aluminum from standard metal. The two metals, the materials can't basically commingle. So body shops have had to take these industrial curtains and make them basically kind of like a hospital curtain would, but it separates an automotive repair bay from one another. And it took up a lot of space. And so when you allocate that kind of square footage, do you really want to eat up that kind of space for the project? So always consider, if you do go down this road and you acquire this business, does your space allocation allow for it? And if not, does it make sense to go and acquire that space, whether it be a building next door, adding on, or doing a mezzanine or what have you? And lastly, capital. I know this is sometimes it seems simple, but it's overlooked a lot. But you got to ask the customer, are they funded? Are they solvent? Do they have the horsepower behind developing this product? Because as a manufacturer, I want to work on prototypes today that result in production next month or next year. And if they're not properly liquid, if they don't have the liquidity to it, it might be something I need to pass on. And then supply chain. There are certain times where, and being a member of the IFAI, I can't tell you the amount of times that I was looking for something I couldn't find. And I utilized the resources the Industrial Fabrics Association has to try and find something I don't have, whether it's a certain type of material that has certain properties to it, or a certain level of whether it's antibacterial or ultraviolet rays fighting, or resistant to certain oils or chemicals. So having resources like the Industrial Fabrics Association to help with my supply chain, you got to really look and see if you have everything you need from your supply chain to be able to deliver this product in the time frame they're looking at. So the bottom line is, do their needs align with your capabilities? And if the answer to that question is yes, then we can move on really to the top 5 questions you're going to want to ask your potential clients. And sadly, if the answer is no, what I would do is refer those people to other members of the association, of the Industrial Fabrics Association, to see if someone else better fits them. Because in the long run, my goal as a contract manufacturer, if I can't do their project, I want to align with other people who have the same, who I believe have the same level of quality and attention and care and customer service, that if I referred them to, it would be a referral that I would be thanked for by both parties in the future. Okay, so let's move on to some of these questions. So questions that I know that I need to ask, first of all, is what industry is the product used in? And as you saw, our company, American National, we really have diversified into a whole bunch of industries way beyond just the consumer sleep and the medical industries. So why do we ask this question? Why is what industry this product's being made for as a question? Why is that important as a question? Well, that's because every industry has a regulating body. Whether we want to know it or not, everything that's made or done has someone that's regulating you. And you need to learn who they are and what requirements there are and they have, and what tests are required to have a product approved. Of course, some of the most strict that I have experience in are the medical. The aviation is really high. So aviation, medical, military, their mil specs. These are some with some really high standards, and really to know if all the work that you're going to charge these customers for, it has to result in a value to that customer, and it has to align with what your operation is able to provide. So that's why that is extremely important. So why is it important? Because every product must adhere to certain requirements of that industry. And second, one of the things that you'll see later on here are ignorance is no excuse for negligence. Trying to claim that you didn't know that a law or requirement existed is no defense. And that comes with great liability. So I urge for you to take great caution and in this step and make sure that you're in tune to that industry. And especially when industries are ever changing. California, we have a law that's passed last year, could be trumped by something that is passed this year. And lastly, it's because you could wind up in court, in jail, bankrupt, or all three. And later in the presentation, I'll show you actual examples of failures that happened. And you'll see kind of examples of companies that have gone bankrupt for something that's connected to the prototype R&D engineering and requirements area. So we want to avoid that at all costs, of course. And the reason is because we want to protect yourself, your business, and your family. For those of us that are family businesses, our family, you have a crossover and a pollination between your family and your business, and what happens in one affects the other. Although you might be filed as a limited liability company or a corporation, there are still things you do, like you have to sign a personal guarantee on a building. And although you think you're behind corporate protections, there are ways that legally and financially they can penetrate those to basically have you personally and your family personally connected to your business operations. So we'll get into a later one. That's part of the webinar series, is all this legal stuff, but that's something to consider here on the front end. Okay, so that concludes question number 1. Actually, we have a number 5 here. Lastly, it's the right thing to do. I can't forget that one. Okay, and question number 2. Where will the product be used? So we just talked about what industry it's in. Now, where it's going to be used. So the environmental conditions of where the product's going to be used is very important as to its design requirements. So not just what industry it's for, but of course how it's used. Here's examples that are very different environmental conditions, and hopefully these will kind of reveal to you where the product's used is important to know. You might have a product that's going to be operating in say Alaska in the winter, where it's freezing, or in the desert where it's very high temperature. So where you have something has operating range from way below 0 to way above 120 degrees. So that could be, maybe it's something that goes inside of an equipment. We did some work for Baxter Healthcare on some blood separators. We made a bladder that went inside of these things. And although your body temperature fluids are 98, 99 degrees, the actual encasement where it went into a blood separating machine and a dialysis machine. Inside that machinery, it was about 125 degrees. So knowing where that product was being used was critical as to design requirements of both the material and the methods by which we assembled or manufactured the product. High altitudes. Chemical exposures. We do a lot of products that get exposed to different chemicals, whether it's an oil or a gas or hydrogen sulfide gas for things that are underground. Direct sunlight. You have things that are in the ocean where you have high salt and high pressure. On an airplane or space shuttle where the environment inside the aircraft changes. An airplane on the ground at sea level is different than a pressurized airplane at 40,000 feet above the ground. And in or on a moving vehicle, I know part of one of the big things that we have in the Industrial Fabric Association is a lot of truck tarps, so things get fastened to something moving. On a building, you have all kinds of things, awnings and things that get affixed to a building. In a hospital, now you've got the FDA involved. In a baby's crib, that's a definitely different environment. Or in or on someone's body, now you've got biocompatibility things that you have to consider. And underground, and I kind of talked about that earlier, the hydrogen sulfide gas and all the different methane gases that weep and are part of that environment underneath the surface of the ground. So these are kind of examples of these different environmental conditions that you're going to want to ask your potential customers to collect this data. This is going to be important. And the next one, who is your customer? So knowing who the customer is helps to determine many things, such as the type of relationship you will have. So for example, if your customer is a massive corporation who has all the engineering team and the horsepower behind an internal laboratory that can do their own internal testing, you're going to have to do very little with that. However, if it's the opposite, you've got some gentleman who invented a product in his basement last week. Imagine the kind of relationship you're going to have. You're going to do a lot more consulting for this company and probably a lot more phone calls to get all the same stuff you'll need eventually to get into the market as a released product. And so knowing who the customer is and what kind of horsepower they have behind them determines how much work and relationship you'll have with that organization. And so the next one, how much administrative support you're going to need, and then next, what kind of price point you can expect that they will need. For example, if your customer is a corporation who sells to dealers, who sells to a store, who sells to the consumer, you have to look at that and look at the price point and look at where you need to be. Is this something that has to be taken outside of the United States for production or assembled, maybe components made overseas and assembled in the US? And you've got to look at who they are and whether or not it fits with how you operate your business. And then what their ability is to sell the product that they want you to make. For example, if you got a company who has no marketing budget, they don't have any special marketing expertise, or they're unfamiliar, maybe a guy who's my customer is a police officer and he invented something that's going to be used in a baby's crib. That's a true story of something I have now. I know that I can't rely on his knowledge because his professional background is not where his product invention is coming from. So I know that his ability to sell is going to be definitely crippled at this point, and whether or not he has the ability to do that. Because if you have limited resources, you really have to determine who your customer is and know what comes with that, and whether or not you can tolerate their lack of resource in this product. This product I decided to take on, although I can't get into details because of non-disclosures, I can tell you that I think his product's going to be great, and I have to make the decision to accept his project knowing that I have a lot more work that I may or may not be able to bill for in order to make the product. But you do gain customer loyalty. Not all customers, they might jump ship, but you might have helped develop this product with them and have provided a lot of input. Our company does use mutual non-disclosure. So if I've custom built a machine or something to be able to make a product for them, they're not allowed to share that without buying it from me first. But we never lock in a potential client or a client to telling them they have to use our manufacturing services. We just tell them that they can't take what they've learned from us and share it with a competitor without first paying a tech transfer fee, which we feel is intellectual property we like to protect. So knowing who your customer is also important for that. And then lastly, down here you see is your customer the government, an online business, a retailer, a wholesaler, a distributor, or a large corporation, or an individual who invented something in his or her garage, for the reasons that I just stated. So that's something to make sure that you're realizing in that first meeting, prototype meeting, is really look into and ask questions to determine your customer, who they actually are, and how they're going to help or hinder the process of product development. Question number 4, who is the end user? All right, knowing the end user helps to determine many things, and that's such as what kind of use the product's going to see, the design requirements of the product, the test requirements, what the duty cycle may need to be. And for duty cycle, I may have an end user who they're going to buy a product, and if they use it once like a Band-Aid, they peel it off and throw it away, it's considered disposable. And they expect it to work once, and they're perfectly happy paying what they paid for it to be able to, if it's say 25 cents, it's disposable, and they throw it away, they're happy with that. But then there are certain products that are single patient use where it might be a cast or a soft boot, and they're going to use this soft boot for 3 months recovering from surgery or recovering from an injury. And they want this product to function. It's a single patient, but they'll use it multiple times over a determined period. And so I know the end user wants or expects to get this life out of it, and it should function properly and not degrade prior to that use. And then there's some products that it's reusable, and it goes from one person to another, to another, to another, and it might be expected to be functional for 3 to 5 years. And so knowing who the end user is important, because that duty cycle is part of the project input information that you're going to want. Labeling and or safety requirements. So for example, if an end user is a mom who's using a product in her home for her infant, there's small parts choking hazard labeling requirements. If it's inflatable, it's got to say that it's not a safety device or a flotation device if it's not. A choking hazard for the bag. So knowing who the end user is, who's going to come in contact with the product that you're making for your customer, that's also a critical component to consider. Packaging requirements, same thing, whether you're labeling a product or outside the box. For example, we talked about an environmental condition. If the end user is an Eskimo in Alaska, it's going to have to be packaged to where the packaging is going to protect the product inside of it from those environmental conditions. We had a product that got stored. Typically, it's commonly used. The end user stores it in the trunk of their car. So it's basically a product that's used for people who are in wheelchairs, and those wheelchairs get stored or moved in the trunk or the back of the car, and then they might have that in there at 120 degrees, 140 degrees when the car's all closed up and sealed, and the packaging may have to protect the product inside of it from those environments, or the product's got to be designed to withstand not only the operating conditions, but the storage conditions used for that product. So knowing who's going to be using the product is important. So the end user could be an infant, an animal, a freight company, a grocery store, a fireman, a factory, a hotel, a restaurant, a school. These are just specific to what we have done. These are all actual projects that I've worked on, and I can't stress enough how really understanding who the end user is affects my ability to be efficient, effective, have a proper product, and deliver something that my customer is going to be happy with in the long run. So that's another, like I said, that number 4 is a really important one also. And question number 5, how does the product work? So understanding the theory of the project or the product and how it operates is key. In order to know how it needs to be made, we first must know how it's supposed to function. So the theory of how it operates. And sometimes I get this information from a customer's website. They might provide me with a technical package that provides me with how it's supposed to work. So we can't really understand how to build it if we don't know how it's supposed to function properly. So that's the first thing here, this subset here. What is its core function? Does it move? Is it supposed to lift? Does it inflate? Does it cushion someone? Maybe it's a Hollywood stuntman who's jumping onto a cushion 20 levels up, and it's supposed to cushion his fall. Does it deflate? Does it cover something? Does it protect something? Does it slide or attach or clamp? Does it hold something else? Does it wrap around something? Does it carry certain weight or carry something? So those are all questions that will answer that theory of how does it work? How is it supposed to function properly? And then what makes it function correctly? So there might be, as shown here, there might be subassemblies that are part of the product. Like my earlier example, a bladder that I made for a blood separator went into a cartridge that went into a machine. So there were 2 other touch points or subassemblies or parts or components that my product couldn't function properly if it didn't seat well in the cartridge, which then seated well in the machine. And so diving down into it that deep is something we don't want to miss an opportunity to gather that data from your potential client. And that's the next one here. Does the product become part of something else? And why is all this important? Why is this question important? Because what can cause the product to not function properly? All right, so we call these risk assessments. And this is commonly overlooked by new clients. They're thinking about how it's supposed to work, and they actually neglect to look at what things can cause it not to work. And a lot of times inexperienced manufacturers will overlook this question also. And shortly we're going to look at some slides of examples of some really huge corporations that miss the mark on this, what can cause a product not to function properly. So that's important to have. So this is a lot of information I've given you already, a lot of details. So how do we remember all of this? So I put into practice tools that I've used. I've developed some internal tools for our company that I've used to try and make this a standardized system. This here image that you see is called a project input sheet, as titled above. And you'll see that I have the general information on the top bar. the company, who the project manager is with my company, whether it's me or somebody else, or maybe it's a team, their contact, the date that I started collecting data, what the customer's project title is. In the first box there, the general information, where you're going to see in there some of the things we've talked about, what industry the product used in, the intended use. And that's hugely important because something could be intended for a specific use and it could be used incorrectly, and it could cause liability or risk or even harm to the person using it. Product dimensions, any known hazards, that's one of the questions we asked. And then we touch here on the general information as the timeline. Where's the design at? Am I 50%? Does the customer have this product 50% design and I have to carry the ball the other 50? How long will it be before I can actually fill in? Once I know where they're at with the design, what's a realistic time frame for a quote? Can I have a quote tomorrow by the end of business today? Can I have it in a week from now or in maybe 2 months from now? And then once I quote it, how long will a prototype take? And then tooling. Hey, if I need tooling, I might need 3 to 4 weeks to get all the tooling made or designed, approved, and then outsourced, or maybe I build the tool in-house and then brought back, tested, and then there's always delays for revisions or problems or things that didn't meet a requirement. And then finally, production. When do I start production? And is it a 45-day production time? Is it 60 days? Is it 25 days? So this is where I like to talk to the customer, and it gives me a feel for what their time expectation is and determine whether or not it's realistic to my ability to respond. So that's that section. Below is the quality objectives. And I want to really just touch on, a lot of people use the military likes to use fit, form, and function. And to define those, for example, on the quality objectives and requirements, the fit or application, here's how we define that. It's the ability of a part to physically interface with, connect to, or become an integral part of another part. So that's what I'm talking about under the fit or application there. And then the form or attributes, we define that as the specific shape, the size, the dimensions, the mass, the weight, or other visual parameters that uniquely distinguish a part. That's what I like to document there in the form or attribute section. And then lastly, we hit on this also earlier, the functionality. The action or actions that a part is designed to perform. That's what that function area is. And so that's kind of that quality objectives and requirements area. Below that, you see a lot of our products are accompanied with some kind of pump. I need to inflate it or put water in it or take it out or vacuum it. And so a normal operating pressure as well as a do not exceed pressure we like to document. The next section below begins the discussion of compliances. Code compliances. So for example, you have statutory, is there one, yes or no? There usually always is. Regulatory, yes or no. And then we have under that safety or fire requirements or any other. And a lot of times customers have no clue. You can ask those questions and they're going to say, I don't know, I don't know, I don't know, and I don't know. But at least at that point, you know that they don't know. Okay, the top right corner, the box here talks about material requirements. That's in this section here. Typically, we like to just document the top 3 materials. Is it a vinyl? Is it a urethane? Is it a fabric, a fiber? Is it foam? We want to look at the top 3 items that the customer is interested in using for their product because each one of those comes with their own requirements. And that's where the specifications have to align with the requirements. The next section below, we have to look at what design inputs the customer is providing me with. Maybe they gave me nothing. Maybe I sat with them for an hour and they talked to me about what the idea of this product that's in their head, or maybe they gave me a napkin. And so did they provide me drawings? If so, what date was the drawings? Because later on down the road, I could be looking at a drawing from January of 2016 and there was one done in October of 2017 I should be looking at. So I like to document that. Any flyer or websites, their material specifications, if they have them. They may or may not have manufacturing instructions. Sometimes another factory's made it a certain way and they have photo documented the actual manufacturing instructions, and that's helpful. Although it might be slightly different from my factory, at least it shows me what they've seen and how they've seen it put together, and I might have a better mousetrap. Or I might be outgunned and someone else might have been doing it better. This allows me to determine that. Next is packaging specifications. A lot of times, potential clients really have no clue as to how this thing should be packaged. They just thought it would come magically the way they want it. Is it in a poly bag? Is there 4 per bag? Does the bag have a barcode label or a product ID or a warning or caution instructions? Is that product put in a box of 4, or 4 per box, and that box of 4 put on a master box of 12, which is then put on a pallet of 36, and there's 4 boxes on row 1 through 6, 6 high, and its weight can't exceed 240 pounds. A lot of times they don't ever get to that point. They don't think that far, but it's your responsibility. So that's a lot of the design inputs that the customer really walk away with, and it reveals what they don't know. And then the next section under quality control, performance requirements. If products has to be inflated or deflated or hold certain pressure for a certain period of time, or it has to inflate and deflate 15,000 times over a 24-hour period, whether or not it has to hold certain weight or be impermeable or have anti-static or antibacterial properties to it, to resist ultraviolet rays. This is where I look at those kinds of things and say, okay, how do I know if this product's good? What has to be done? Does it have visual standards? Is there a visual requirement? Hey, look, it needs to function, but it can't be too big, or it can't look like it's got a blemish to it, or the printing can't be smudged or smeared or have dots around it. So all these are performance requirements that you want to collect from your customer as best as possible. And this may simply just open up discussion to clarify later. And then below, test methods. Do I have to take this test to a destructive test? Do I have to blow it up and capture at what pressure it blew up at? Or do I have to put it on a digital force gauge tester and pull it, and it has to exceed 10 pounds of pressure before the material fails? And then AQL level. That's always important because your customer probably expects you to test every one. But if I've got 5,000 parts and they take 4 minutes to test, they can't afford to pay for that. So then you determine an acceptable quality level of a batch size, a sampling size, and testing maybe the first 2 of a production lot, the middle 3 and the last 2 to determine consistency. But maybe I'm only testing 9 parts for every 500 parts. So determining their expectation of that or asking the question is good to know. And a lot of times, I'd say 90% of my customers start off with, I'm not sure, Chad. We're looking for you. You're the professional. So know that that's going to be an expectation that might be set upon us to deliver. And then that last part about packaging, do they have a packaging spec, yes or no? And that's where I just start discussing that with them. So going back to the slide, this is simply a tool that I use. There's a back side of this that we'll see at a later webinar if you so choose. The next recommendation I have is to practice it. Don't just have this tool and ignore it. Use it. Be consistent with it. Use it every time because it helps to do this 4th bullet point, which is standardizing a system. Real quickly here, I know we're already 43 minutes into this, and I want to have time for Q&A at the end. But these are examples of design failures that happen every day. If you look at this top one, this is a recall for electric bike tire, a wheel. And the axle failed. So somehow, somewhere along the way, they designed an axle where its job function was to hold the person riding this bike, and it failed somewhere along the way. This next one below, this is a kind of odd one. This is a company who actually makes these off-road sport utility vehicles, these off-road, and this has a crash hazard due to the braking system. And it's all due to air in the brake lines. So a requirement would be that someone bled the brakes and that someone tested that they bled the brakes and they know that the brakes work and they don't fail. In this case, they missed the mark on that. They had brake lines with air in them that caused the brake to fail, causing injuries. And they had 4,000 units that they had to recall. So these are examples. The next one here, a children's product. As I had mentioned earlier, we do children's products. And there's a recall here on the top in the blue writing below the red box here. You'll see January 2016, the Consumer Product Safety Commission and the National Highway Traffic Safety Administration voluntarily recalled this infant car seat because of the handle. The carry handle can crack or break. Imagine that you're carrying your baby in this carrier, and the plastic breaks and the child falls to the ground. However, we're comforted to know that the defect here of the handle doesn't affect the performance as an actual car seat in a crash. Not really comforting to me because they might not get injured in a car crash, but carrying them from the car to the house, this handle fails. And another one, Graco, a very large company with a lot of quality and engineers on staff. This convertible car seat, because of mislabeling. This was literally because it was mislabeled, and that goes back to my point earlier about knowing how this product should be labeled. This one is kind of an odd one. The product seemed to designed okay. However, if you look, this was a chandelier that's sold by Home Depot, and the halogen bulbs that were sold were a part of it. And remember, earlier we talked about being part of something. Well, this didn't work without the lights, and they're using halogen bulbs. And look what it says, that the chandeliers, that those halogen bulbs actually melt parts in that. So someone didn't connect the dots that the bulbs emit a certain degree of temperature, and all the components around it need to withstand that temperature. Or let's use LED lights. And there were 10,500 units sold there. So that's just another example. Takata, I'm sure you've heard of this one. Takata is a very big company known as the pioneers and the experts in airbag manufacturing. They filed for bankruptcy protection because of all the failures they had of their airbags not functioning properly. My car itself, a GMC that I have, was recalled as well. And again, on my slide earlier, we talked about proper engineering and doing your due diligence prevents this kind of thing, although it doesn't completely abate it. This is one I was involved in. We make nap mats for children, and it's against the law for you to expose kids in preschools to toxic chemicals. You're supposed to protect them from them. And the Center for Environmental Health in the state of California, they randomly tested 12 nap mats from a variety of manufacturers. We at Happy Child Products happened to be, we're number 4, as you see on this list. And we were fire retardant free, and we were PVC free, and we had no phthalates, mercuries, halogens, or heavy metals in this products. So we were found to be compliant with their expectations. And here's this public shaming for those that chose not to. So they have found high levels of flame retardants on the following nap mats that are exposing children unnecessarily to toxic flame retardant chemicals. So again, our due diligence on the design and what foam we chose to use, what materials we chose to use, made a difference for us specifically. So I figured I'd share that with you. Now, kind of rounding it out, this is kind of a funny little cartoon. This top left corner here, what the customer described. This is what they described on your project input sheet. This is what got budgeted. Look at that. The only thing here is a string dangling. And what the engineer designed, something totally different than what was described or budgeted. Then here's how manufacturing installed it. I think this one's hilarious. And what marketing advertised, a lazy boy hanging from a branch on a tree. And of course, we struggle with documentation. Look at that. That's what got documented. And then now what the customer finally received. This is what they actually got. This next funny cartoon here, what the customer was billed for. They billed for a roller coaster. And then what they actually wanted. Here's what they actually wanted. And you compare that what they described. It's close but different. So I thought that was pretty comical, and I figured I'd share that with you guys. This is a 8,000-pound Humvee on top of air bladders that we RF weld here in Corona, California. And we are, of course, sharing the load of that 8,000 pounds over 2 tires, over 4 tires, 2 of which are on these bladders. So quality is critical, so we want to demonstrate it. And we show this to people. We actually have a video film that we used on a retail commercial that the Hummer actually drove off of these bladders and snapped the 3/4 inch plywood. However, our air bladders remained intact. So I think that one thing that you ensure that you portray is that you can deliver quality. And I hope these slides and this presentation help you to determine all the things that will help you to make that right decision on whether or not the project is right for you, that you can deliver the quality that they expect, and if so, that you can demonstrate that when the project concludes. Well, with 10 minutes to go, I want to open it up for questions. Again, I thank you all for your participation in this webinar. There is a series that we're doing that I'm sure Magda will inform you about, but I could open up it to questions now if you'd like.
Chad, I'm going to start off with a question. This is Magda. How much time do you generally allow for testing, and what types of, how do you decide what types of tests that you're going to need to do, and do you outsource any of those tests?
Yeah, great question. So there are pre-market tests that are required. So if before I even take a product on, there might have been tests of raw materials, or there might have been tests of the abrasion resistance or puncture resistance of a product, or the permeability. So sometimes you'll get lucky and already have some of the tests that are going to be required on the materials prior to, or you're from your suppliers prior to you ever getting the project. So there are pre-market tests. And then for the Consumer Product Safety Commission, they require, and here's the hard part with certain types of tests, some tests are periodic. And the Consumer Product Safety Commission says, hey, look, you're the manufacturer. We're not going to tell you the periodic testing you need to do. We're going to tell you you've got to determine what that should be and stick to it. So for example, a pre-market test means I've tested the product for its functionality and all the different requirements. And a test might be that I have to test the flammability of something. And yes, we use a third party. You always have to do third party testing. Now, kind of like an attorney, I like to think of it this way. I never want to conduct a test that I don't think I already know the answer to. An attorney will never go to trial and ask a question he doesn't know the answer to. So if I'm testing for flammability of product, you'll bet that I have contacted if it's a foam product or a fabric, a textile, or a material product, that I've already contacted my vendors and looked at how the test performed, whether it passed an ASTM standard or whether it tests a specific, like maybe Green Guard standard, which is a VOC tests. There are enormous amount of tests that could be potentially there. A resource for you there would start off with the Consumer Product Safety Commission. They've got a great website. They have a portal for manufacturers, and they have it for industries, and you can look at, hey, if I'm making a product for a child, and they do have resources to help direct you. You can always contact the Small Business Ombudsman. There's a gentleman I work with, Neil Cohen, with the Consumer Product Safety Commission, and that's his title, and he was extremely helpful in helping me to determine which kind of tests I needed. For example, a small parts test, if the end user is going to be a child under 3 years old, then I have to have a small parts warning or a small parts test, like a button on a shirt or clothing. On a baby, they can't be able to bite it off because they're going to be biting that button. So it can't be toxic to them, and it has to withstand a certain pull test. So each industry does have test requirements. They could be pre-market tests. They could be, you always have to have tests in your production line, and then you have to have the test at the end of your production line to determine that, yes, this batch of products, these 1,000 parts I just made, met the requirements of the customer. Now, I want to throw out one caution. You have to determine how much skin in the game you're going to have. If your customer has dictated, I want you to test it this way, and you do that, then you're totally outside of any liability. But if you provided, hey, look, you should inflate this to 10 pounds, if you provide that input to them, you have liability over defending how you chose that. So you got to be real cautious as to what you provide as test requirements. I would always lean on the customer association or a government entity like the CPSC to determine that kind of testing for you.
A great answer, Chad. If anyone has questions, please feel free to type them into the question box. I have another question for you. When you walk away from a job, you get a lot of people that come in. You have some professionals that come in, but you also work with inventors and people that come up with ideas. When do you know if a job is too dangerous or too many risks for your business, or simply the people are not far enough along in their process? What helps you determine that decision?
Okay, great question. There are three types of liability. There's that liability which I assume, and being a medical device manufacturer, I understand that my products will be used in the medical world to treat a medical condition, and I have to ensure I deliver that. This product that says it's going to do this will do that. So I think number one is the confidence in your ability to deliver. So if I know that I've got to take a patient and he has a bed sore stage 3 or stage 4, and then my product has to alternate pressure and relieve the pressure from that patient so that it can heal or prevent a bed sore, then I accept that liability. So I assume certain liability. Then there might be certain components I'm not comfortable with. If I'm not comfortable with the radiolucency of a product, maybe, or the sterilization of a product, maybe I say, you know what, I'm comfortable making it for you. I know I can make you a good product, but I can't ensure its sterility. So I'm going to give it to you. I'm going to sell it to you as unsterile. And I've deferred that liability to somebody else like Sterigenics or another sterilizing organization. And their job is to deliver the piece which I want to defer. And then lastly, there's liability I just don't want to assume. And that's where the rubber meets the road, where, you know what, I can't be a part of this product because either I don't believe in its theory of operation, or I can't get behind its functionality. You know what, I really don't think doing this for a baby is going to work or function, or it's just too risky. Or if I get feedback from a regulating agency and the IMO, like the International Maritime Organization, or the CPSC or the FDA, or somebody along the way says, you know what, this product, my problem with this product is it's intended to be used like this. And I'll give you an example. One of a lady that she was not my customer, but she's a fellow business person in the baby world. She basically invented a baby cradle that's a piece of foam wrapped in a fabric, and you were supposed to have it used only on the ground, and the baby could be on the ground with it, and it was safe and fine, and everyone loved it. The customers loved it. It was very successful. Then someone chose to use that product inside a crib, and a baby rolled off of it. And because it was a piece of foam, the baby got sandwiched between the actual foam cradle, and it basically, the baby got tipped up with the foam thing pushing the baby onto the side rail, where she had an inflatable, little inflatable baby pad, and the baby suffocated and actually and died because of the product being used incorrectly. The product was never intended to be used in a crib, and a loss of life. So the CPSC made her put all these warnings and cautions on there. And again, it wasn't a design flaw. It was an intended use problem. So they chalked it up to, okay, that we need to put better warnings and on there, and they did that. Another baby died because the same failure. They used it outside of its intended use, and the CPSC had the power to shut her down because it was determined that the product was so successful, people were going to use it more and in different ways than it was intended, and there was no way to remedy that, and they shut her business down. So to answer that question, Magda, there are things like that happen, and if there are any red flags for you in the process, or you feel your potential customers making claims that you can't defend, you don't want to be part of it.
Yeah, that's great advice, Chad. If you're interested in finding out more about legal issues, the prototyping process, development, setting up a time schedule for them, please tune in and sign up for our other prototype education webinars in this series. Chad, thanks so much for being here and sharing your expertise. I hope everyone in the audience enjoyed today's webinar. A link will appear on the pop-up survey if you're interested in registering for additional ones. There'll be a brief survey at the end of this webinar. Please visit the events page on ifai.com for additional events coming up. And thank you for joining us today.